somewhere roughly 12.7 billion light-years away, two of humanity's most powerful space observatories stared at the same tiny region of the sky and uncovered something that is forcing astronomers to take another look at how quickly the early universe could build enormous structures. The two observatories are the James Webb Space Telescope and the Chandra X-ray Observatory. Understanding why they were used together is important, because each telescope sees a completely different side of the universe. The James Webb Space Telescope launched in December 2021 and operates near the second Lagrange point, or L2, about 1.5 million kilometers from Earth. Its enormous 6.5-meter primary mirror is made of 18 hexagonal segments coated with gold, allowing Webb to collect incredibly faint infrared light from some of the most distant objects ever observed. That infrared capability is especially important when astronomers look deep into cosmic history. As light travels across the expanding universe, its wavelengths become stretched. This phenomenon, known as redshift, moves extremely distant light toward the infrared part of the spectrum. Chandra works very differently. The Chandra X-ray Observatory has been operating in space since 1999 and was designed to detect X-rays produced by some of the hottest and most energetic environments in the cosmos. Gas heated to millions of degrees can produce intense X-ray emission, and because Earth's atmosphere blocks X-rays, Chandra has to observe from space. Webb can reveal distant galaxies through their faint infrared light. Chandra can reveal enormous clouds of superheated gas surrounding those galaxies. When the two are combined, astronomers can build a much more complete picture. That is exactly what happened in a region known as the Chandra Deep Field South, which overlaps with the JWST Advanced Deep Extragalactic Survey, commonly called JADES. This region is already one of the most intensely studied parts of the sky. Webb has been using its infrared instruments to search for some of the earliest galaxies in the universe, while Chandra has accumulated extremely deep X-ray observations of the same general region. Inside this cosmic laboratory, researchers identified a remarkable structure known as JADES ID1. Webb revealed dozens of galaxies packed into a relatively small region of space. In total, researchers identified at least 66 galaxies associated with the structure. That alone would have been fascinating. But there was a much more important clue. The galaxies appeared to be part of a larger gravitationally connected structure known as a protocluster. A protocluster is essentially an early-stage galaxy cluster. Instead of the mature, organized clusters we see in the nearby universe, protoclusters are still assembling. Gravity is pulling galaxies, gas, and dark matter together, gradually building the enormous structures that will eventually become galaxy clusters. But proving that these galaxies were actually connected was difficult. From Earth, galaxies that are separated by enormous distances can appear close together simply because they happen to line up along our line of sight. That is where Chandra became crucial. As matter falls into a developing protocluster, enormous amounts of gas can be compressed and heated. Eventually, that gas can reach temperatures of millions of degrees, producing X-rays. When astronomers examined the same region with Chandra, they detected X-ray emission associated with a large cloud of extremely hot gas surrounding the galaxies. That provided an important additional piece of evidence. The combination of many galaxies occupying the same cosmic region and a surrounding cloud of extremely hot X-ray emitting gas is exactly the kind of evidence astronomers look for when determining whether they are seeing a genuine developing cluster rather than a random alignment. And then the discovery became even more interesting. The light from JADES ID1 has traveled for more than 12 billion years to reach us. That means Webb and Chandra are not seeing this structure as it exists today. They are seeing it as it looked when the universe was only about 1 billion years old. The universe is now approximately 13.8 billion years old. So this is a glimpse into an era when the cosmos was still extremely young, when the first generations of galaxies were only beginning to organize themselves. And that is where the scientific puzzle begins. According to many existing models of cosmic structure formation, building massive, gravitationally connected systems takes a significant amount of time. Galaxies must form, dark matter must gather into increasingly large structures, gas must fall inward, and gravity must gradually assemble everything into larger systems. JADES ID1 appears to have reached a surprisingly advanced stage extremely early in cosmic history. Researchers estimate that the structure contains roughly 20 trillion solar masses of material. For comparison, the total mass of the Milky Way, including its dark matter halo, is generally estimated at roughly 1 to 1.5 trillion solar masses. That means JADES ID1 already contains many times the mass of our entire galaxy, despite existing when the universe was barely a billion years old. This does not mean physics has been broken. There is no evidence that gravity suddenly stopped working or that some unknown force assembled the structure overnight. The mystery is much more subtle. The question is whether current models are accurately describing how quickly matter could organize itself during the universe's earliest billion years. There are several possible explanations. One possibility is that galaxies formed more efficiently in the early universe than many simulations predict. Gas may have been converted into stars faster, allowing large galaxies to appear sooner. Another possibility involves dark matter. Dark matter provides much of the gravitational scaffolding on which galaxies and galaxy clusters form. If dark matter gathered into massive structures earlier than expected, it could have provided the gravitational framework needed to assemble galaxies much faster. There is also another possibility. JADES ID1 may simply occupy an unusually dense region of the early universe. In that scenario, it would represent a rare cosmic head start rather than evidence that the entire universe was forming clusters at this speed. And this distinction is extremely important. One unusual structure is not enough to completely rewrite cosmology. Astronomers need more examples. Interestingly, JADES has already produced several other protocluster candidates. A separate team previously identified additional groups of galaxies in the same survey region that appeared to be associated with one another. But JADES ID1 stands out because it has the additional X-ray evidence from Chandra. The other candidates remain interesting possibilities, but without the same clear hot gas signature, astronomers cannot yet make the same level of confirmation. This is why combining Webb and Chandra is so powerful. Webb tells astronomers where the distant galaxies are and allows researchers to study their properties. Chandra reveals the incredibly hot gas surrounding the developing structure. Together, they provide two completely different pieces of evidence describing the same cosmic system. Finding this kind of structure is extraordinarily difficult because the signal is incredibly faint. The galaxies are billions of light-years away, and their light has been traveling across an expanding universe for most of cosmic history. The X-ray emission is even more challenging. Detecting a faint cloud of million-degree gas at such a distance requires extremely sensitive observations and careful analysis to separate the signal from background noise and unrelated X-ray sources. Researchers must also determine whether the galaxies really are at similar distances rather than merely appearing close together from Earth's perspective. That requires measuring their redshifts and comparing their positions in three-dimensional cosmic space. Only after combining all of these observations can astronomers begin to establish that the structure is genuinely connected. And that is what makes JADES ID1 so interesting. It is not simply a collection of distant galaxies. It appears to be a massive structure caught during one of the earliest stages of cluster formation.